Good morning to all the listeners. Today's topic is about principle of infrared spectroscopy. So this is also known as vibrational rotational spectroscopy. Infrared spectroscopy lays in between UV visible spectroscopy and microwave spectroscopy. Infrared region is considered as a fingerprint for functional group identification. When infrared light falls in the molecule, it is able to generate vibrational and rotational transitions within the molecule. That's why it plays a vital role in the identification of functional groups. So it is specific for the identification of various functional groups which are present in the given compound. When IR radiation is given, vibrational and rotational levels involved in excitation from ground level to excited level. Amount of energy, that is a quantized amount of energy, is required for vibrational transitions within the molecule. And just to be discussed, it will be the fingerprint for functional group identification. Each and every functional group have their unique absorption region so that it will identify the various functional groups which are present in the given compound. Basically, higher light falls in the molecule is able to generate two types of transitions within the molecule. This is the main principle involved in the vibrational rotational spectroscopy. Whenever higher radiation falls in the molecule, it induces stretching vibrations, which leads to change in the bond length, bending vibrations, which used to give change in the bond angle. Bond length changes called stretching vibrations. Angle of bond will be varied called bending vibrations. Stretching vibrations are nothing but, so when we are elongating and compressing the bonds. So when bond length will be elongated and get compressed, leads to formation of transition in the bond length. Bonded atoms will be oscillated along their axis, is called stretching vibrations. Whenever stretching of bonds are possible, it may leads to symmetric or asymmetric stretching is possible. Symmetric stretching stands for if we are elongating and compressing the bond in only one direction, if we are doing in the symmetric way, same direction. So when we are elongating, pulling out or pushing inside in only one direction is called symmetric stretching. When you take a linear molecule, we can expand the bonds in this direction so that both the bonds will be elongated up to the equal distance, which is called as symmetric stretching. Whereas asymmetric stretching stands for whenever elongating and compressing with which are in the opposite direction. One is dragged outside, second is pulled inside. If such a kind of transition is possible, uneven type of symmetry, uneven type of stretching is observed. One of the bond is coming out, means elongated, and the second bond, because of inward pull, that will be concised, so that we observe asymmetric stretching within the molecule. So whenever CH2, water or carbon dioxide, either it may be bent molecule or linear, we can apply this symmetric or asymmetric kind of stretching. Symmetric stretching stands for, so equal direction, equal possibility, equal stretching of bond length is possible, so that molecule retains symmetry even after applying this, stretching vibration. When asymmetric stretching is there, one of the bond is coming out and the second bond is going inside, so that uneven bond lengths are generated, which induce asymmetry within the molecule. One of the bond will be elongated and the second bond will be concised. This is called asymmetric stretching. And second kind of transition is bending vibration. Bending vibration stands for we are not going to change any bond distance or bond length, But so by taking the atoms of terminal centers, we can change their bond angle. Angle present between the bonds will be varied. Bending vibrations are again categorized into four types: scissoring, rocking, wagging, and twisting. When we compare the energy requirement for stretching and bending vibration requires comparatively less energy in order to bring the angle towards inside and also towards outside compared to stretching vibrations. Stretching requires change in the bond length. Bonded atoms are held together by electrostatic forces of attractions. That's the reason why we require large amount of energy for stretch the bond compared to bend it. That's the reason why bending vibrations are least energetic when compared to stretching vibrations. Again, bending vibrations are categorized into scissoring, rocking, wagging, and twisting. Now let us go one by one. Scissoring is nothing but whenever bonded atoms are come together and going apart to each other in the equal direction, just like a scissors. How scissors is coming inside and outside, in the same way scissoring is also carried. Terminal atoms are getting inside and going outside, just like a scissor. That is called a scissoring process. And second is about wagging. Rocking. Rocking stands for whenever terminal atoms are oscillating in one direction and also coming back in the opposite direction. So both the atoms are moving in one direction. That is called rocking. How the pendulum is oscillating in the wall clock, in the same way here rocking also leads to the oscillation of two atoms in only one direction towards right side and also towards left side. This is called rocking type of bending vibration. And next is about wagging. Central atom remains within the plane and the remaining two terminal atoms will move up and move down. So in that way, here both the atoms are going up and down with respect to the central atom. This is called wagging. So how the dog tail is moving in up and down direction, in the same way wagging also leads to terminal atoms are moving up and down direction. So this is about wagging. So we are moving above and below of the plane with respect to the central atom. And next is about twisting. Twisting is nothing but whenever we are doing the bending of terminal atoms, one is going up and so second is going down. So twisting, we are twisting the bonds in this direction. One of the atom is moving up and second atom is moving down, and simultaneously they are used to exchange their position, which is called twisting of the bond. In this way, we can define the principle of infrared spectroscopy by means of stretching and bending vibration. Stretching stands for transition in their bond length. We can elongate the bond and even we can concise the bond. Bending stands for if you are going to change their bond angle, it is called bending vibrations. Stretching vibration causes change in the bond length, whereas bending vibration causes change in the bond angle. Symmetric stretching is equal length of stretching is possible. We are able to elongate the bond at the same time and we can concise them. Asymmetric stretching stands for one of the bond is coming out, another bond is going inside, so that uneven bond lengths can be observed. Asymmetry is generated within the molecule. So this is about stretching. Next is about bending, which is the least energetic type of transition, is associated with four various subcategories within this: scissoring, rocking, wagging, and twisting. Scissoring stands for whenever terminal atoms are coming inside and going outside, just like a scissors. How scissors is working in the same ways here, atoms are getting inside and going outside. rocking, whenever terminal atoms are subjected to oscillation like a pendulum, so that two atoms are moving in one direction and also coming back in another opposite direction. This is called rocking. And wagging stands for central atom remains in the same position, but terminal atoms are moving up and down, just like dog tail, how it is moving up and down direction. In the same way, terminal atoms are moving in above the plane as well as below the plane. And the twisting stand for one of the atom is going up and second atom is going down, and simultaneously they used to replace their positions. All this is about principle involved in infrared spectroscopy. Hope it is very helpful for your preparation. Thank you. Thank you very much.